Greetings and welcome, friends. We are going to up the ante. We are going to up the algebra today. We're putting more letters in my equations, and it's going to be awesome. I'll help you. Don't worry. I'll not literally hold your hand, but I'll metaphorically be here for support as you are attempting to solve these equations with more letters than numbers at times. So yeah, today's lesson is called like rewriting equations and formulas. And here's this first idea. An equation that has two or more variables is called a literal equation. Okay. To rewrite a literal equation, solve for one variable in terms of the t'other variables. Possibly. All right, so notice this equation, by the way. Maybe I should put a comma there. It says solve the literal equation 3y plus 4x equals 9, and I'm solving this equation for y. So notice here's the problem. There's a y and an x in here. What? That's crazy. And I'm targeting the y, and if I want to solve for that y, that means I want to get everything else away from the y. I want the y by itself. And I'm going to pretend, pretend this 4x, pretend that x is just some number, right? So if this was 3y plus 12, right? Because x was 3 and 4 times 3 is 12, right? Or just 3y plus 40, okay? If this was just some number, I could move it away from the y, right? There'd be two things happening to y. It's being multiplied by 3, and it's being added by the number 4x. So which should I move first to get y by itself? What are your thoughts? If we were pretending that this x was just some number here. Yeah, I'd subtract that from both sides. So I'm going to subtract 4x from both sides. X is just a number. Pretend. Now, you notice a challenge here, a problem. I've got 3y. These x's canceled out. Actually, I'll write it down here. Equals negative 9 and negative 4x. I can't quite combine those yet. So I'm going to write those separate. I like it. And I'm going to write the x first because it's got a variable. So I'm going to write this as negative 4x plus 9. If you wrote that as 9 minus 4x, that's equally good. I'm just kind of preemptively preparing us for the future when it will be better to write a variable before a number. Okay, so we're just pretending that's a number. That's all. Now, how do I get y by itself? It's being multiplied by 3. What's the inverse? Amity, yes. Divide by 3. Now, I'm dividing both sides in their entirety by 3. I could write all over 3 like this, or if you wanted, you could write over 3 over 3. Doesn't matter, same difference. I'm gonna actually go with this one, but even if you wrote all over 3, you'd still get to this next point if you wanted. So those 3's cancel out. I get y equals, and I'm gonna write this as negative 4/3 x. And I'm writing the x on the side. You technically could write the x up in the numerator as well if you wanted, but I'm a fan of just right on the side there. Not down below, that doesn't work, but on the side, it's just fine. Plus, and what's 9 divided by 3? 3. So here is my equation solved for y, right? Y is by itself, and it's written in terms of x, right? It's written in terms of the other variable. I don't know what y equals, but if I knew what x was equal to, I could plug it in and I could tell you what y equals now. All right, so I'm solving this equation for x. Side note, parallel universe, same problem, different goal. Watch this. What if I changed this on us? What if I wanted to solve 3y plus 4x equals 9? What if I wanted to solve for x? Yeah, this is awesome. Yeah, I know, it's weird, like there's multiple variables here. This is so weird. So if I wanted to solve the equation for x, notice it's exactly the same equation. Yeah. Just because it makes a really cool point for us. But if I wanted to get x by itself, this time I'd pretend that the y is just some number, right? This is just 3 times 2 or something like that. I don't know. And what would I have to move to get x by itself? I'd have a positive 30 or something like that, and it's being it's being multiplied by 4 and added by that. What should I move first? Minus 3y from both sides. I like this. So 4x equals, now I can't combine those. I think you guys would agree. So I'm going to just write minus 3y plus 9. And now what could I do to get x by itself? What? Ooh, not quite. Not quite. All right, no worries. No one even knows who was talking then. No one even knows anyone talked. Because the internet cannot hear you. All right, divide by 4, and I could write all over 4. Or I'm actually going to write this as over 4 over 4. Just every term gets divided by 4. I'm a fan of that myself. So I'm going to have x equals negative 3/4 y plus, and I can't reduce that, so I'm just going to leave it as 9/4. All right, so it's the same exact equation, bless you, but I could solve it for any of its variables. And when I solve it for a variable, I just kind of pretend that the other variable is a nombre. All right. Oh, these are pretty good. All right, we good? We good over there? Oh, yeah, we're good. Let's do these monitoring progress ones, just because it's weird solving these, right? It's a little weird. I'm sure it takes a while to get used to. I've been doing this for decades now. But you guys, I understand it's different. It just done but different. That's fine. So, all right. So notice I like how they actually highlighted which variable they're solving for. You might have black and white, so you could kind of put a box around the one that you're solving. All right. Here, I'll do 1, and then I'll have you guys try 2 and 3. All right, so to solve for y, I'm pretending the x is a number. I'm going to deal with subtraction before I deal with multiplication. Well, right, yes. But I'm not going to actually write anything in for it. X could be any number right now. But yeah, I just want to, we're pretending it represents a number. It definitely does that. I don't know which numbers I'm going to commit to, but later on it could represent all sorts of numbers. And let's see. So I would move the x to the other side, treating it like it's a number. And now how could I get y by itself? Being multiplied. What's the inverse of multiplication? Division. Right, and everybody gets divided by 3. So I've got y equals, watch this, x over 3, watch this rewrite. I'm going to write that as 1/3 x. That'll help us out later. I realize right now I'd be like, why on earth would I write it that way? You don't have to write it that way now. All right, 9 divided by 3 is 3. So, internet friends, you can try these next 2 problems at home, while me and my friends in real life are doing the same. let's see if I can... Here, internet friends, I'm going to catch us up on problem 2 while some of my team here might be following along, and the rest might be working on problem 3. So, to get y by itself, the first thing I did was move the x, subtracting 2x from both sides. And now we're going to be super tempted to combine these, but we got to realize these are not like terms. One's got an x, one does not. So I'm going to have negative 2e is equal to negative 2x plus 5. One of my students wrote 5 minus 2x. That's perfectly fine. Perfectly fine. 5 minus 2x, you're fine. All right, later on, we'll prefer it the other way, but it doesn't matter right now. And then let's see, y was being multiplied by negative 2, so the inverse of multiplication is division, and I would divide everybody by negative 2, and I'm going to go y equals, negative over negative is positive, 2 over 2 is 1, that's just plain old x, and 5 divided by negative 2, that's negative, there's only one minus sign there, minus 5 halves. All right, let's see how my team does on question 3. All right, I was trying to remember where Caillou was from. I'm not a fan of Caillou myself. Nothing to do with where he's from. I'm just, his cartoon I'm not impressed with. Yeah, Devin, be cool. Oh, thank you, sir. Here we go. To get y by itself, I'm going to move that 8x, subtract 8x from both sides. Right? I can't combine those. I'm going to write the 8x first, though. Negative 8x plus 20 equals 4y. Now, how can I get rid of that 4, friends? Divide everybody by 4. Everybody. Everybody. Negative 8 divided by 4 is negative 2x. 20 divided by 4 is 5. That equals y. And tell you what, it's a little weird that the variable I solved for is on the right side, so I'm going to just flip this whole thing around. I'm going to write this as y equals negative 2x plus 5. Yep. All right. Hey, oh, check this out. Oh, man. You can also rewrite problems that are formulas, or area, or surface area, or volume, or rate times time equals distance. All right, so formula shows how one variable is related to one or more variables. A formula is a type of literal equation. So formulas you guys might know is A equals B times H. You might know that perimeter is equal to 4s for a square, right? Rate times time equals distance is another formula, right? Maybe you know the area of a trapezoid formula is half the height times the sum of the bases. right? So a whole bunch of formulas with a whole bunch of variables in them, and I can rewrite the area of a rectangle formula. I could solve for the base, or I could solve for the height. Here, Ethan, you can put your phone away forever. Thank you, sir. So let's look at example 4, and I realized I skipped a bunch. Ethan, be quiet as well, thank you. So here we go. I skipped a whole bunch of problems because those problems, I'm not a fan of where the book placed those. I think those problems will make more sense. I think in chapter 7 is the one where I would place those. We're in chapter 1, you're right? Exactly. So Jimmy, it says you own a rectangular lot that is 500 feet deep. Oh, okay. Here, let me show you the picture. This will make more sense. I was thinking like deep as in like Minecraft depth, like you dig into the ground and you go down 500 feet before you hit bedrock. But they're saying that from the front of the property where it touches the road or it is adjacent to the road, 500 feet back is how far the property goes. And then there's this width, which is the same as the width here, which is the frontage of the road. It says it has an area of 100,000 square feet. So this area is 100,000, right, feet squared. So that's literally the number of little 1x1 squares that I could fit there, where those 1x1s are measured with feet, okay? So 100,000 little square feet fit in there. You pay for a new water system and you are assessed at $5.50 per foot of frontage. All right, so our frontage is going to be this dimension, and our water cost, oddly enough, is based on the frontage of the lot. Don't know why. So here it says, for part A, find the frontage of the lot. Now, I realize that the frontage is the same as W here. You guys agree? This dimension is the same as this dimension, is the same as this dimension, is the same as that? Yeah, those are all W's. So I'm going to, for part A, let's write a formula. And I happen to know the area, I know the length, and I don't know the width. But I do know that length times width, 500 times W, is going to equal the area of a rectangle. I wrote one too many zeros there. Zeros. There we go. So if I want to find the frontage of the lot, I could solve this formula for W, right? And so what I did here was length times width equals area was the formula that I came to the table with. I knew this formula when I showed up. All right, so to solve for the W, oh, that's weird. They actually solved this twice. That's bizarre. I wouldn't do this problem their way, but that's fine. That's their problem. To solve for W, what would I do? Divide, right? Yeah. Divide by 500. Right? And I'm going to get W equals 200. And if this is measured in feet, and this is measured in square feet, what do you think W is measured in? Also feet. Yeah. So there you go. The alternative way that the book started with this, they started with A equals L times W and solve for W first, which W is being multiplied by L, and you could divide both sides by L. Which is weird, right? I happen to already know these values, so that's why I plugged them in first. And so you'd have A over the length is equal to the W, or W equals A over the length. So they were just kind of showing that you could have made a W formula when you happen to know the area of a rectangle. And then if I plugged in 100,000 and 500, I still would have gotten the same number there. So it's a little bit different. Then they asked us this question: how much are you assessed for the new water system? So it says it's $5.50 per foot of lot frontage. So I believe my cost, I could call it C, is going to equal 550, or just 5.5 times 200. Yeah? No, I was just, instead of writing a dot for multiplication, that's how I did it. Nope, not in this case. So 5.5 times 200 is 1100. What do you think that's going to be measured in? Well, let's actually do a unit analysis. So this 5.5 was measured in dollars over feet. I multiplied by 200 in feet. And notice what happens here. The feet cancel out, and I'm left with dollar. Right? Dollar, hey. So this is going to be measured in dollars Americano. Right? So the lot is 200 feet wide, and the cost for the water system is predicted to be that amount. All right, let's, oh, I like this. Let's do monitoring progress question 7. Looks like this one. Question, comment, observation. Yes, you may. All right, solve for H. This is the area of a triangle formula in case you're wondering. So the height is the perpendicular dimension to one of the sides, which you are ascribing the base as being, and that height goes from the opposite vertex to that. And that represents the area of that triangle, which is the same idea as the area earlier, as if I divide this into a bunch of tiny squares. You might be like, but Mr. Waddy, how can I make this into a square? And you could kind of combine a whole bunch of these ones to make squares if you wanted. But nonetheless, the area of a triangle is equal to half the base times height. They want me to solve for H there. H is being multiplied by half B. We'll deal with this one step at a time. How do I get rid of multiplying by a half? What's the inverse of multiplying by a half? Dividing by a half, but that might weird us out. I don't know if you've ever written that before. There's another way you can deal with it, multiplying by 2. But dividing by a half is still correct. So let's see. So I'd have 2a is equal to bh. And how can I get rid of the b here? Yeah, I can divide it, right? I'm just pretending that b is some number. So that would be like if it said 5h, and I'd divide both sides by 5. Here it just says BH, so I'm going to divide both sides by B. So I got 2A over B is equal to H. And then we'll just flip it around for fun. So H equals 2A over B. All right. Ooh, I'm going to do question 8 with you as well. Affirmative. All right, here we go. What? Oh my goodness. Let me draw a picture of what's going on here. So if I have a cone, I'll help you through it, don't you worry. All right, some of the dimensions here of the cone. You've got, in terms of dimensions for a cone, you would have the radius. This dimension along the edge of the cone, if you were to like slide down the edge of the cone here, that is called the slant height. The dotted line on the inside of the cone is the regular height, but that doesn't show up for surface area. And surface area is the amount of like paint, if I was to paint the outside of this cone, would be surface. Volume would be kind of how many cubic units could fit inside of it if I was to say fill it with some ice cream, right? So here's our formula. S is equal to pi r squared plus pi r L. And I want to solve for L. There's my target. I've got, look at all these letters. There's even a Greek letter in here this time. Oh dear. So this just represents some number, and L is being multiplied by some other number. What should I get rid of first? I'm going to move this piece. This is positive, and I can just move it all as one big chunk. Watch this. Minus pi r squared from both sides. All right, this is weird looking. Are these like terms? No. Man, this is weird, right? It's a little bizarre. S minus pi r squared equals, these canceled out, and I'm left with pi r L. All right. L is being multiplied by pi r. So how could I get rid of the pi r? Pi r is just some number now. If this was 8L, what would I do to both sides to get rid of the 8? See, I think my students are still writing, which is why they're not guessing. Right, if this was 15L, how could I get rid of the 15? You would divide. I like it. I knew someone would know. So I'm going to divide both sides by pi r, and I can divide by both of them at the same time if I want. So I'm going to divide this by pi r and this by pi r. Everybody gets divided by pi r. So I'm going to have S over pi r, right? Isn't this weird with so many letters? Like, what happened to the numbers? There's only one number in this, the 2. That's weird. Minus, now guys, check this out. These pi's cancel each other out. That's weird. And r squared divided by r to the first. We haven't gone over any properties of exponents. I don't know if you guys know this, but that's just going to be r. I don't know if you guys know that rule yet. Over here, the pi's cancel out, the r's cancel out, and I'm left with just L, which is what I wanted. Good old slant height. And let's flip it around. Not in their form right now. Theoretically, I could get a common denominator or something like that, but yeah, we won't bother. Let's see. Here's some other formulas for you to be aware of. How am I doing for time? Guys, this is a tricky lesson. Right? Look at, there's like hardly any numbers on this. If you have like a sibling and then they see you do on your quest tonight, they're going to be like, what is going on in math class? Where are all the numbers? Yeah, they're going to be like, I'm 1 year old. Why am I even talking? This is crazy. Who spilled my alphabet soup on your math homework? Right? That's what they'll end up saying. So here's a couple other formulas. A conversion formula from Fahrenheit to Celsius. Is this one? Question, comment? Sorry. Don't worry. Your brain will slowly get stronger. So here's 3 new formulas for you. Celsius is equal to 5/9 times the difference of Fahrenheit and 32. Interest, simple interest that is equal to the principal times the rate times time. And the rate is in a decimal form. And then rate times time equals distance. So guys, there's some new formulas for us. And I could even just make up a formula. Right? I could just kind of make up my own letters and you guys would be able to solve for an unknown letter, even if you'd never seen that before. It's all doable with your skills. Let's see. Here we go. Example 5. It says rewrite. Oh my goodness. Wow, there's so many. All right, we're going to try at least to get 2 more examples in here. It says solve the temperature formula for F. So we had Celsius is equal to, what was it? I always mix it up. 5/9 times F minus 32. So I'm trying to solve for the F. Now, there's a couple different ways you could do this. I could distribute 5/9. Don't worry, it's going to get better. You're going to get stronger. I could distribute 5/9, but then we're going to have some more fractions here. Instead, I'm going to multiply by the reciprocal of this. I'm going to multiply both sides by 9/5. Right, we saw that multiply by reciprocal concept a little earlier when we dealt with the 1/2. You guys remember when I multiply both sides by 2? Watch what happens here. Even if you didn't know this was a trick, hopefully you believe that it works. Multiplying both sides by 9/5, the 9s cancel out, and those 5s cancel out. It was like a one combo, like move, just pow, and just like bam, that fraction's gone and over on the other side. 9/5 times capital C is going to equal F minus 32. The rest of my purple box went away over here. So to solve for F, how could I move 32? Plus it, right, because it was being subtracted. Add 32 to both sides. Now, are these like terms? No. So I'm not going to be able to combine them. I'll just write that as 9/5 C plus 32 is equal to F. Or flip it around, F equals 9/5 C plus 32. All right. I realize this is weird, guys, right? But the trick is just pretend everything else except the variable you're solving for is just a number. Just gotta pretend. All right. Bop dee bop. Repeat dee bop. Now, the benefit of rewriting formulas like this is that you could then, instead of having a Celsius formula, which is what I started with, now I have a Fahrenheit formula. Right? The first formula worked great if I knew the Fahrenheit. The second formula works great if I know the Celsius. Right? So if I know, like, actually, let's just do a check. Let's convert 100 degrees Celsius. What is that in Fahrenheit? So watch this. Let's just do a little formula check. F is equal to 9/5 times 100 plus 32. 100 divided by 5 is 20. 20 times 9 is 180. And I get F equals 212 degrees Fahrenheit. Does anyone know what happens at 212 degrees Fahrenheit? Water turns to steam. Water boils at 212 degrees Fahrenheit, and that's part of the way they designed Celsius. They said, hey, wouldn't it be great if just like 100 was when water boiled? And they made up their own temperature for when that worked. Does anyone happen to know what 0 degrees Celsius represents? Yeah, someone said it. They said freezing. 0 degrees Celsius is the freezing point of water. Let's actually do that conversion real quick, just to show you. So F is equal to 9/5 times 0 plus 32. I get F equals 9/5. Anything times 0 is 0. And I get Fahrenheit is equal to 32 degrees, which is the freezing point of water. Question, comment? Yeah, I think that's a good idea. Yeah, if we have time. Let me just do example 7. So I'm skipping example 6. So flip a couple pages here for yourself. Do you feel your brain leveling up with math, or are you just talking about your stitches? All right. So guys, mis amigos, example 7, it says, using the formula for simple interest, you deposit $5,000 into an account. So that's the P. P is equal to 5,000. All right, that earns simple interest. After 6 months, friendly friends, 6 months sounds like time. And then they want to know the annual interest rate. Because they want annual, I'm going to call 6 months 0.5. Is 6 months is the same as 0.5 years? Yeah. And then they say the account earns 162.50 in interest. All right. So guys, if I want to find the interest rate, I want to find R. Devin, track with me. I want to find R. Let's rearrange this formula and find a rate formula instead of an interest formula. So R is being multiplied by P and T. How do I undo multiplication? Division, man, he's got it. And watch this. Let's do a 1-2 combo. Let's divide by PT. Same time. Yeah. So I'm going to get I over PT is equal to R. Or let's flip it. R equals I over PT. And so now that I have a rate formula, right, I rearranged my formula, I can now plug in all of the components I have and solve for R. So that means R is going to equal 16250 divided by the principal, 5,000, multiplied by time, which I converted to years, 0.5. And it's nice that this formula is already solved for R. Right? I could now teach a spreadsheet to do this formula for me, and it would work all of the time. And I get R equals 0.065. And that means, yeah, those are actual numbers. And that means R is 6.5%. All right? So thank you for watching, Internet friends. Have a great day.